Determining if a triangle is possible. How many different triangles can you draw? Well, recall that triangles can be classified according to their side lengths and the measures of their angles. So in classifying a triangle by its sides, you have a scalene triangle where no sides are congruent. So this would be a scalene triangle. An isosceles triangle has at least two sides are congruent. It's usually two, but it can be more. An equilateral is when all three sides are congruent. And it is worth noting that equilateral triangles are considered to be isosceles. You can also draw triangles based on their angles. An acute triangle has all three angles are acute or less than 90 degrees. So for example, this triangle right here. So let's say we have an 85 degree angle here and a 60 degree angle down here and a 35 degree angle here. This would be considered to be acute. A right triangle contains one right angle. And right angles measure 90 degrees, and sometimes they're noted by small boxes, as well as 90 degrees for that number. And an obtuse triangle contains one obtuse angle. Let's say this is 110 degrees, which is considered to be obtuse. There's another property that applies to triangles. It's called the triangle inequality property or triangle inequality theorem. The triangle inequality property or triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Well, what does this mean? Well, it means that if you take the three sides of a triangle and add them up in pairs, the sum is always greater than, cannot be equal to, the third side. If this is not true, then it is not possible to construct a triangle with those given side lengths. So for example, I have 5 plus 3, and that sum is 8. And if I was to take these two lines and bring them in, you can see in the diagram down below they don't meet. There's actually a little black space in between there. So that's why you don't get a triangle with side lengths 5, 3, and 10. Similarly, if you had 6 and 4, they're a little bit longer. If I bring these down, they're still not going to touch each other until they actually reach and become overlapping with the side of 10. So therefore, 6 plus 4 is not greater than 10, so it cannot form a triangle. And finally, the last example that we have is 7 plus 5. Well, 7 plus 5 does equal 12, and if I was to take these two and bring them together, or rotate them, they will be brought together to form a triangle. So again, the triangle inequality theorem is that the sum of the lengths of any two sides in a triangle is greater than the length of the third side, which allows for those two sides to come together to form that extra vertex of the triangle. Now let's put the triangle inequality property to work. Determine if the sides of length 5 centimeters, 8 centimeters, and 12 centimeters can form a triangle. Well, in order to do that, we're going to test out all the sum pairs that we have to see if they are greater than the third side not included in the pair. So we'll start with 5 and 8. If I do 5 plus 8, I get 13, and that is bigger than 12. So the inequality is true for the first set. Now if I try the second set, 5 and 12, so the first and the last, 5 plus 12 gives me 17, and that's also bigger than 8, so this is also true. And the last one that we're going to test out are the second and third sides, and if I add those up, I get 8 plus 12, which is 20, and 20 is bigger than 5, so that's also true. Therefore, yes, it is possible to construct a triangle with sides of length 5 centimeters, 8 centimeters, and 12 centimeters. Determine if the sides of length 3 feet, 4 feet, and 9 feet can form a triangle. Similar to the last example, we are going to test out all 3 pairs to see if the sum is greater. So we'll start with the first two. 3 feet plus 4 feet, is that greater than 9 feet? Well, 3 plus 4 is 7, which is not greater than 9, so therefore this one is a no. Now let's do the first and the third. 3 feet plus 9 feet, is that greater than 4? Well, the sum ends up being 12, and 12 is greater than 4. So that's a yes. And then we have the second and the third, so that's 4 plus 9, is that greater than 3? Well, the sum is 13, and 13 is greater than 3, so that's a yes. Now, because our first one was a no, our final answer here is also no. It is not possible to construct a triangle with sides of length 3 feet, 4 feet, and 9 feet, because as we saw in the example, if I had something that was 3, this is 9, and this is 4, these two would come together and I would get this amount. Here would be the 4. And then this amount here would be the 3, and you only get 7, so there's an extra space in the middle. So again, the answer here is no. Let's try some more problems. Determine if the triangles below can be formed with the following side lengths. So in our first one, we have 4 centimeters, 7 centimeters, and 10 centimeters. So let's check them all. So we have to do 4 plus 7. Is this greater than 10? Well, we get 4 plus 7 is 11. 11 is greater than 10. Okay, so that one works out. Now let's do the first and the third. So that's 4 plus 10. Is that going to be greater than 7? We get 14 is greater than 7, so yes. All right, now let's try the last set, which are the second and third. 7 plus 10, is that greater than 4? Well, when we add these two numbers up, we get 17, and that is greater than 4. So all 3 of these inequalities work. Therefore, yes, these side lengths will form a triangle. Now let's look at our second one. We have 24 millimeters, 20 millimeters, and 30 millimeters. Let's first start off with our first and second. We get 24 plus 20. Is that greater than 30? When we add them up, we end up getting 44, and that is greater than 30, so far it works. Now let's look at our first and our third. So that's 24 and 30. And when we add those two up, will this be greater than 20? Well, we will get 54 here, and that is greater than 20. So yes, that one also works so far. Now let's try the last set, the second and third. So we have 20 plus 30. The question is that greater than 24? Well, when we add up 20 and 30, we get 50, and that is greater than 24. So all 3 of these inequalities worked, therefore, yes, this also forms a triangle. Now let's look at number 3. We have 7, 9, and 16. So we have 7 plus 9. We'll do the first two. Is this greater than 16? Well, when we add up 7 and 9, we get 16 also. And it's not greater than 16. It's actually equal to. Let's also try the other sets of sides. So next, let's do the first and the third. So that's 7 plus 16. Is that greater than 9? When we add these two up, we get 23, and that is greater than 9. And now let's do the last one, or the last two, which is 9 feet and 16 feet. So 9 plus 16, is that greater than 7? When we add these two up, we get 25, and that is greater than 7. However, because our first one did not work, it was equal to instead of being greater than, the answer here is no. Now let's look at the last problem. We have side lengths of 9 inches, 13 inches, and 24 inches. Let's again start with our first and second with 9 and 13 and see if that's greater than 24. When we add up 9 and 13, we get 22, and that is not greater than 24. It's actually less than. All right, let's check the others. We'll do our first and third sides next. So we have 9 plus 24. Is this greater than 13? Well, if I add up 9 and 24, I get 33, and that is greater than 13. And then let's do the second and third sides. That'll be 13 plus 24. Is this greater than 9? When we add those up, we get 37, and it is greater than 9. However, our first two, when we did the smallest and the medium and added those two up, that was a smaller amount than the longest side. So therefore, our answer here is no. And this slide shows again the solutions that we just found on the previous one. We found that the first one, all of the inequalities worked, so yes, it does make a triangle. Same with number 2, all of the inequalities worked correctly, so that one's also yes. Now this third one, it was equal to, and it was not greater than, so therefore this one is no. And then the last one, the very first inequality, 22 is less than 24 instead of being greater than it, so that's the reason why we were unable to form a triangle with those side lengths. In those last examples, we saw what needed to be true about the side lengths in order to make a triangle, and also what was required. So what generalizations can we make about given segment lengths and whether or not they can form a triangle? Take a moment and pause this video and think about it, and when you're ready for the answer, unpause it. Well, what we found in our examples is that if we add up the two smaller side lengths to see if their sum is bigger than the longest side length, then we form a triangle. And if it was a true inequality statement, then it makes a triangle, and if it's not a true inequality statement, then it doesn't make a triangle. So if you'll remember, in our first example, we had 5 centimeters, 8 centimeters, and 12 centimeters. And if we add up the two smallest sides, which are 5 and 8, we get 13. And 13 is bigger than 12, which is the longest side. Then it makes a triangle. And if we use our second example that we just did, we had 3 feet, 4 feet, and 9 feet. When we added up the two smallest sides, 3 and 4, the sum is 7, and 7 is not greater than 9, so therefore it does not make a triangle. So again, the shortcut is if you take the two smaller side length values and add them up, that will be the ultimate test as to whether or not the sides form a triangle or not.